Hi everybody, this is lesson 13 and we're converting between fractions and decimals using equivalent fractions. So our essential question is just that. How can we convert efficiently between decimals and fractions? Okay, this is a really neat lesson. I like the way that we kind of think about fractions and decimals and how they relate to each other in a non-scary way. I know that decimals and fractions can be scary. So let's take this piece by piece and just first start out talking about times in real life where we would use fractions and decimals. So some ways that I have talked about in class, and hopefully you're thinking of when I say decimals and fractions, we've talked about fractions and decimals with money. We can think about this with cooking, like if we're measuring things out. There's lots of different ways. We've talked about it with sports, measurements. Can you think? Sorry about that. I'm not sure what happened. I think I hit something on accident. Okay, so go ahead and if you can think of any others, you can add them in here. Let me know in class which ones that you added in here. Where else have you seen fractions? Okay, oh, sorry, I thought of some other ones. Interest rates. A lot of times, percents, we go back and forth between fractions and decimals as well. So I just want to make sure you had those things down. All right, what is the value of the number 2.25? Well, when you see that, I really want you to think of money. If you think of it with money, it's really going to help. The way that we can write that is we can write it as 2 and you know that 0.25 ends in the hundredths place value, so we can actually think of this as 2 and 25 hundredths. 2 and 25 hundredths. That's a D. Okay, 2 and 25 hundredths. We can actually write that as a mixed number. 2 and 25 hundredths. So the really cool thing, the thing that I love about decimals is that you can, however you say them correctly, is how you write them as a fraction. So this is 2 and 25 hundredths. It's the whole number 2, and then 0.25 means 25 out of 100 because it ends in the hundredths place value. Okay, how do we rewrite fractions in simplest form? We need to divide by common factors. You may have also heard the term GCF, which is the greatest common factor. And right below this, we're going to actually do this with 2 and 25 hundredths. So off to the side, I want to show you, if you know that 25 over 100 ends in 5s and 0s, hopefully you remember that means that they're both divisible by 5. And that would give us 5 over 20. But again, that also divides by 5. And that would give us 1 over 4. Okay, sorry, kind of smushed that in there. And that's to kind of show you the long way. So you can do it like that and you can get the right answer. But if you know the GCF, which is the greatest common factor, you know that it's not just 5 and then 5 again. You might know that 25 and 100 both actually divide by 25. So now we say 25 divided by 25 is 1, and 100 divided by 25 is 4. Don't forget that it's the whole number 2. So this is actually equal to 2 and 1/4. I've also tried to talk to you in class about how this has to do with money. 25 cents is equal to what coin? What coin? One coin represents 25 cents. It's a quarter, and that's what 2 and 1/4 means. It means 2 and 1/4. So these relate back to each other. So the more that you deal with quarters or eighths or thirds or halves, the better you're going to be at going back and forth between decimals and fractions. And for this specific example, the money, 1/4 is 25 cents. So 1/4 is the same as 0.25. Okay, what if we had 2.025? 2.025. Now I don't end in the hundredths place value. I end in the thousandths. So this is 2 and 25 thousandths. Well, if 25 went into 100, it's got to go into 1,000 as well. So let's go ahead and divide this by 25. And no, you still can't use a calculator. So let's try to make this as efficient as possible. I know that 25 divided by 25 is going to be 1. You might already know what 1,000 divided by 25 is because you know what 100 divided by 25 is, but 25 goes into 100 4 times. So if you want to show your work off to the side, you can, but we know that 25 goes into 100 4 times, and that's exactly 100. So then when I bring down the 0, there's nothing for it to go into. So it's just 4, and then the next place value is 0, 40. And that makes sense because 100 divided by 25 was 4, so 1,000 divided by 25 would be 40. So this one is 2 and 1/40. And that's right there. So we don't need to do that last problem on page 77. So remember, how you say it, and when I say how you say it, I'm talking about the decimal 2.025. I know a lot of us say 2.025, but the correct way to say it is 2 and 25 thousandths because of where the place value ends. Okay, let's go on to the next page. Let's practice an exercise 1. So on page 78, I can see that the 0.218 ends in the thousandths place value. So let's actually kind of do a diagram up here. And I'm just going to go 1, 2, 3, 4, 5. So if that was a number that we were dealing with, the 1 is in the tenths place value. Go ahead and write this. The 2 is in the hundredths. Hopefully you know the answers before I'm saying them, but if not, that's okay. Write them out. Thousandths. 10 thousandths. And 100 thousandths. Had to kind of curve around there. Okay, so in the first one, since it's got 3 place values, I know that that is the thousandths. So really what you do is you do 218 over 1,000. And then you reduce it. That's really not too bad. So 218 over 1,000, 16 hundredths. It ends in the hundredths. For C, I've got 2 and 72 hundredths. And then the last one, 1, 2, 3, so tenths, hundredths, thousandths, that's got to be 10 thousandths. So 5 over 10,000. Okay, pause it and try simplifying those and see how you do. Okay, if you unpause it, hopefully you reduce them as much as possible. A lot of kids say, well, how do I know when it's all the way reduced? And the tricky part is if you don't have a calculator, you just kind of have to say, all right, is there any other number that goes into both of them evenly? Remember, dividing by 1 won't change the value, or sorry, it won't change the digits. So if you divide them both by 1 and that's the only number that goes into them, you can just leave it how it is. Okay, so for A, I see that it's an even number. If I divide those both by 2, I get 109 over 500. Okay, for part B, I know that they're both even. So a lot of kids, you're going to say 8 over 50. And that is true. 8 over 50 is equal to 16 over 100. But you've got to reduce it one more time. So if you're going to do it this way, you have to be able to say, okay, now is there anything else that goes into both of them? And you can divide them both by 2 again and get 4 over 25. Now, if you want, you can say, all right, this divides by 4 and this divides by 4. So 16 divided by 4 is 4. And 100 divided by 4 is 25. And look, I got the same answer both ways. It just was one less step if you divide by 4 instead of dividing by 2 and then dividing by 2. All right, how'd you do for C? Did you know that 4 goes into both of those? If you didn't, you probably cut them in half and got 36 over 50. And this is totally fine. It's actually easier to cut in half in your head. So if you don't know 72 divided by 4, you might know 72 divided by 2. So just make sure you're doing the same thing to the top and the bottom. So if I have 72 over 100, I know they're both even, so I can divide them by 2. And then I know both of these are even, so I can divide them by 2. And I get 18 over 25. Or if you divide it by 4 from the beginning, you would get 18 over 25. Don't forget about the 2. It's a mixed number, 2 and 18/25. Okay, and then the last one, if you divide by 5, that's the only step that you have to do. So if I have 5 over 10,000, I want to divide this by 5. I want to divide this by 5. This is just equal to 1 up top, but on the bottom, it's equal to 2,000. 2,000. Be careful. So 1 over 2,000. Okay, how did you do? If you didn't get one, rewind it and kind of listen to the explanation again. Make sure that you're writing down all the steps for that problem. All right, here's what we're going to do now. We are going to take fractions and make them into decimals. We're only going to do it for the ones that are the most efficient. So when we get over to page 79, a couple of those are going to be challenge questions, which you can try or you don't have to. So what are decimals? What are decimals? They represent part of a whole, just like in a fraction. So I'm talking about the numbers that come after the decimal place. Okay, the meaning of decimal to relate to the place values. Let's put C diagram at top of page. And that was the 0.12345 where we talked about the place values. Okay, 300ths. If your bottom number, your denominator, is like 10 or 100 or 1,000, this is really cool. Again, however you say 3 over 100, that's 300ths. So if the second place values, so 0.12345, it would help if I wrote them all in there. Okay, 1, 2, 3, 4, 5. If the hundredths is this second number here, then I want the 3 to end there. So if it's 300ths, I need to be careful that I'm putting in everything else how it is. So this is equal to 300ths. You can check it by saying it out loud. Yes, 300ths. Okay, what if it was 3/20ths? This one, it doesn't go in. I'm sorry, 20 isn't a place value. 20 isn't 10 or 100 or 1,000, but it can go into one of those. So which one does 20 go into? If I have 3 over 20, I want it to go either into the tenths or the hundredths, and it does go into 100 evenly if I multiply it by 5. So multiply this by 5. And that equals 1,500ths. Very cool, because look, now I can write 1,500ths just like this. Okay, how about you try this one on your own? 10 over 25. So try 10 over 25 and tell me, what does that go into evenly? Does it go into 10 evenly, 100 evenly, 1,000, 10,000? How far do you have to go to figure it out? Okay, it is 100 if I multiply by 4. So then I do 10 times 4. So here's the work. And this is 40, so 40 hundredths. It's also equal to 2 tenths, and here's why. If you reduce 10 over 25, this is kind of a roundabout way, but just to show you, if you divide both of those by 5, you get 2/5, and then 2/5 is equal to 4 tenths. And if you notice, 4 tenths and 40 hundredths are equivalent to each other, because in math, you don't need the second 0 if it comes after the decimal, after the last digit in the decimal. So 0.4 tenths is equal to 40 hundredths. Okay, for the last one, this one's a little tricky. You could do 8/40ths. You could put that equal to a number out of 1,000. It doesn't go into 100 evenly, but another cool way to do this is I can reduce it to tenths. So if you can see that 40 divided by 4 gives you 10, you can do 8 divided by 4, and that gives you 2. So your answer is 2 tenths. Okay, it's pretty neat how you can find a denominator that goes, that 40 can go into evenly, or 25 can go into evenly, or even reducing this one to get 2 tenths. Okay, for exercise 2, you only have to do the second and fourth one. So turn the page to 79, and you don't have to do the first one or the third one. If you are up for a challenge, or if you kind of want to say like, you know what, let me just try it on a calculator. This 16 goes into 10,000 evenly. And for this one, 32 goes into 100,000 evenly. I just don't see the efficiency in doing that by hand on paper, but you can do this one. So for 7/5, make it a mixed number first. 7 divided by 5 is 1, and there's 2 left over. Okay, so go ahead and try to change this one into a decimal, and then same thing with the last one. Change this one into a decimal. So in order to change it into a decimal, you need the denominator to be either 10 or 100 or 1,000. So pause it, try it, and then see how you did. Okay, the denominator here, 5 goes into 10 if I multiply by 2. So then I do 2 times 2 and I get 4. So 1 and 4/10 looks like this, 1 and 4/10. This was the math here, times 2 times 2. Okay, for 35 over 50, 50 doesn't go into 10, but it does go into 100 if I just double it. So all I need to do is double it. So then all I need to do is double this, and I get 70. So 70 hundredths looks like this. If that's 70 hundredths, then this is 7/10. So that means that I actually could have done 35 over 50. I could have gone reduced it to be out of 10. 50 divided by 5, well, look at that. That's pretty neat. 35 also divides by 5, and I get 7. So 7/10 and 70 hundredths is the same thing. Okay? If you did the first one and the third one, ask me in class. I already have the answers for those, but I want to see if you can get those. You kind of need to figure out what the multiplier was from 16 to 10,000 and figure out what the multiplier was from 32 to 100,000. If the only thing stopping you from doing those two is a calculator, I give you permission to use a calculator, but only on this one and this one, just to kind of see the patterns and how you can figure it out. These ones are challenging, so let's put a little C next to it so you know it's a challenge question. Okay, don't forget to do the summary, and then in class we will complete the independent practice. Okay, see you later.